So question number 6 in your homework asks you to draw the mechanism of shift space formation. All right, so the way that we're going to do that, so you're going to have a lysine reacting with a carbonyl, all right, in these mechanisms. We're talking about a shift space. All right, so we have our lysine here, we want to have it to be a deprotonated lysine. So we want to have the lone pair of electrons there because the lysine is going to act as a nucleophile. All right, so the lone pair of electrons are going to attack the carbonyl, all right, pushing the electrons up onto the oxygen, but they're going to go ahead and get protonated. So you can draw this as an acid here. You can draw it as water or just an H+. H+ is the easiest if you want to just do that. All right, so now in the second step, we have our lysine. It still has 2 hydrogens on it because we haven't lost any. We started with 2 hydrogens. We still have 2 here. All right, it now has a single bond to that carbon, what used to be the carbonyl carbon, and that carbon is attached to an OH group now. All right, now our goal of shift space formation is we want to have a double bond between our nitrogen and our carbon. All right, those extra electrons are still going to come from the nitrogen, but right now those electrons are locked up because they're bound to 2 hydrogen atoms there. All right, so we're going to need a base, first of all, to deprotonate one of those 2 hydrogens, so remove it, all right, which is going to free up the lone pair of electrons then to form our double bond. All right, and now this is going to give our carbon 5 bonds, and it's going to want to lose the hydroxide here as water. So those electrons are going to come over here, find an H+, and in the end, we're left with our lysine. It's going to have a positive charge on it. It's double bound to the carbon that used to have the carbonyl. And the carbonyl, the oxygen, has left as water. So that is our end product. There's the full mechanism.